Welcome friends to the 22nd lecture on HSC practices in offshore and petroleum engineering. In module 2, we will see an example on FMEA study in this lecture. We already said FMEA is one of the methods which is helpful in identifying the hazards present in electromechanical systems. There are certain requirements for performing FMEA which we will discuss as the example goes ahead. FMEA is generally reported in a standard format which we discussed in the last lecture. So, we have to identify different failure modes and the causes for these failure modes, and if they fail, the perceived failure, what would be the consequences on the component as well as in the overall performance of the entire system, and if the system have any safeguard which can compromise or which can counteract on these consequences, then we have to account for those safeguards present in the system, and ultimately one can give recommended actions so that the overall performance of the system can be completely improved by either altering or redesigning the components present in the given system. So, please pay attention to the graphical image shown on the screen now. We are taking a very simple example, just everybody can understand this FMEA very quickly because it needs a mechanical system to understand. So, we have taken an automobile model. The automobile model is shown in the grey sketch here. It is a passenger car which has got 4 wheels as you see here in the black here. This is the front wheel and the rear wheels. This is a driving shaft. This is a rear wheel shaft. This is what we call as a propeller shaft in the design, and this is micro controlled sensors are located on the fore as well as the rear wheel shafts. There is a sensor S3 located here which is connecting the driving shaft to the propeller shaft, and the 4 wheel shaft has 2 sensors S1 and S2 which will be actually feeding information to the central microcomputer which gets information from the sensors S1, S2 and S3, as well as the microcomputer will now control the opening and closing of the valves V1 and V2. So, that is the mechanical functioning of the whole arrangement for which we are going to write the FMEA worksheet now. Let us quickly see the working of this. For example, this being a driving shaft, when the speed of the vehicle is very high, which is indicated by the sensor connected to the propeller shaft which receives this shaft speed from the rear wheel, then when the brake is applied, you know there is going to be retardation in the driving shaft speed. So, that will be sensed by S3 which will bring information to the microcomputer. The microcomputer will now say that the driving shaft speed has been reduced and there is an extensive brake being applied. If the reduction is sudden, it will alert the sensors S1 and S2 which will open the valves V1 and V2. The moment these valves are opened by the control mechanism operated by the sensors S1 and S2, then the braking power applied on the driving shaft is reduced. Therefore, the shock which is expected to happen on the car because of the sudden brake applied on the driving shaft will be now released because the valves will open and the braking energy will be relaxed and released, and then the driving shaft will receive less retardation because of the applied brake. Subsequently, when the brake comes to normal position, the sensors S1 S2 react that, feeds back to the computer, and the microcomputer again closes the valve V1 and V2 through the sensors S1 and S2, and the vehicle goes ahead. So, the very purpose of this particular system which is having sensor controlled mechanism of S1, S2 and S3 is that when the brake is applied suddenly, this will cause damage to the passenger in the car. We want to relax this sudden impact caused in the vehicle by a sudden brake which is now controlled by opening and closing of the valves V1 and V2. This being the function of the whole system, let us now look at the objective of the whole problem. The objective of the problem is to prevent, so let us say, detailed understanding of the components and the system is carried out. So, let us quickly see what actually we are looking at. The objective of the system design as expected is to prevent the locking of the front wheels. When this locking will occur, in general this will occur when sudden brake is applied to the driving shaft. How it is done? We already saw that the sudden brake applied to the driving shaft will be sensed by the sensor S3. The sensor S3 measures actually the speed of the driving shaft, this also indicates the speed of the rear wheel, of course. It passes information to the microcomputer. Microcomputer present on board. The microcomputer then indicates the speed sensors. It now controls the speed sensors S1 and S2 located on the front wheel shaft to open or close the valves V1 and V2. That is the function. Now, if the speed of the vehicle falls significantly low, because of the sudden brake, valves V1, V2 should open, which will be controlled by the sensors S1 and S2. Once these valves are opened, the braking force will be reduced. So, that is the whole action, what we are understanding from the mechanical system which has been shown to you on the screen. Having said this, our job is to find out the components now. FMEA is a component level analysis. So, FMEA need to identify in step number 1 the first set of components which need to be analyzed and their interrelationship, which is qualitative. Now, the components here are sensors S1, S2, S3 and valves V1, V2 and of course, the microcomputer. We have taken a very simple example to really illustrate how FMEA can be easily carried out for this problem. We will take one more example later which will be relevant and which will be slightly complicated compared to this, using a cause and effect diagram. We will talk about that. So, we identified the components. In step number 2, we have understood the interrelationship between the components and that of the whole system, which is also qualitative. In step number 3, we have to identify the failure modes. We already discussed in the last lecture what are the possible failure modes which could happen or perceive in electromechanical systems. Let us say the first one could be sensors can fail to give output. That can be the first failure mode, that is no output from the sensors. That could be the first case. Second could be valves fail to open on demand. We already know the valves V1 and V2 are controlled. Basically the opening and closing of these valves are controlled with the sensors S1 and S2. There is a possibility that the sensors S1 and S2 sends the signal, but there is a mechanical fault in the valve fails to open when it is required to be opened. Similarly, once the valves are opened, obviously the speed will improve or the braking force will decrease, comfortability will be reached, and once it is reached, valves should close automatically by the control mechanism of sensors S1 and S2. But there can be a failure mode where valves fail to close when required. As long as the valves remain open, the braking force will be reduced, and therefore there is no effective braking system happening in the whole passenger car. So, the valve should close once the braking force has been released up to a required value. The other failure mode can be microcomputer and associated electronics fail. They will not give any output. So, let us say these are my possible failure modes for this specific example. So, we have to draw an FMEA worksheet which should include my risk priority numbers. We will talk about this slightly later. Let us try to write down the FMEA worksheet in a qualitative mode without giving any risk priority numbers and identifying the sequence of failure. We will first talk about the qualitative analysis part. Let us say we are talking about FMEA anti skid braking system for a passenger car, which is a very common phenomena in most of the automobiles now. So, we have the component, as we identified, the component can be front wheel sensors S1 and S2. There can be a failure mode as discussed earlier like this. The sensors can fail to give output. So, no output. That can be a failure mode of the sensors. The failure effect, which can be a consequence arising from no output from the sensor, can be computer will assume that one wheel has stopped. That can be a possibility because there is no output from the sensor. Therefore, sends a signal to open the relief valve. So, the result will be results in partial loss of the front wheel brake that is a consequence. So, comment recommendation, observation can be, it will result in uneven braking, on the front wheels. So, what should be the advice? The advice could be an alarm system is required to indicate failure of sensors, and it should switch off the computer. On the other hand, the vehicle should now get shifted to the manual mode. So, that can be one of the analysis for a component where sensors S1 and S2 on the front wheel fail to operate. Now, the second could be the front wheel valves component could be V1 and V2. There are two issues here. On demand, the valve does not open, fails to open. On demand, the valve does not close. So, both are possible. When the valve does not open, one front wheel could lock on heavy braking. Because depending upon whether V1 is not opening or V2 is not opening, corresponding wheel could lock on heavy braking. Not desired, that is not desired one. So, the recommendation could be test facility to check the brake power is required. One has to examine this independently. If the valve fails to close, it will result in partial loss of the front brake or front wheel brake. That is the failure effect or the consequence. It will result in uneven braking on the front wheels. So, the recommendation could be additional secondary valves may be required. I mean, that is only a suggestion. The next mode of failure could be, I will rub this here and write it here itself. Rear wheel sensor S3 the failure mode could be no output signal from the sensor. Failure effect could be microcomputer will have no reference speed. No reference speed. Therefore, it will not attempt to close or open the valve V1 and V2. So, in such case the recommendation is alarm system is required. So, The next could be microcomputer, that is the component. There are many possibilities here. No output signals, to the walls V1 and V2, because microcomputer is the one which is going to fail now. So, both front wheels could lock on heavy braking. Action could be alarm system is required. The other failure mode could be no output signal to one of the walls, either V1 or V2, either one there is no supply, there is no signal to walls, either one of them, result in partial braking, alarm system required. The third failure mode could be spurious output to both the front walls. I mean, output is not desired, but output is supplied. Is not required, but is supplied by the computer. Total loss of front wheel braking, alarm system is required, computer should be switched off, or computer control should be bypassed, it should go to the manual mode. So, one can easily analyze various issues related to the functional aspect or interrelationship between the components, which could have a cascading effect ultimately on the overall system failure, which can be done using an FMEA analysis, which is one of the powerful tools to do qualitative and quantitative analysis both for electromechanical systems. So, therefore, FMEA is a systematic tool to identify the effects or let us say consequences of a potential failure it can also identify the method and sequence of failure, thereby it can recommend or recommend to eliminate or reduce the chance of failure. It can advocate redesign, it can advocate further testing, etc. Therefore, one can say that FMEA generates a living document which is useful to anticipate a failure and then prevent it from occurrence of it. Now the question comes, when to use FMEA? When to use FMEA? Essentially, it is very effective when used in the design stage. At least it should be used before the final design is released. So, FMEA is one of the mandatory study which is to be conducted for assessing the performance of electromechanical systems. Now, what is an objective of FMEA? The primary objective is on failure prevention. It is not on detection. So, it is not a post accident scenario, it is not an hazard identification, it is much more than that. It is very effective because it works towards failure prevention itself, whereas hazard analysis tries to find out what are the possibilities of occurrence of failure. So, it is detecting the failure, then you have got to take steps to avoid that kind of failure, whereas in FMEA study it directly addresses the critical factors which should be corrected, which should be modified, so that the failure is prevented at the design stage itself. Therefore, friends, FMEA is considered to be one of the most effective tool to assess the performance of electromechanical systems. Therefore, FMEA is actually a standard process followed to assess the performance of electromechanical systems at the product stage itself. So, it is mandatory in case of new products development, it is a standard reference in case of product revision. So, in both cases FMEA studies are referred as a standard document, as you see in the blackboard now. There are two types of FMEA. One is what we call as design FMEA. Design FMEA actually examines the function of a component, present in a system, subsystem or a main system. It identifies the potential failure of the component in terms of improper material choice, inappropriate specification, etc. So, therefore, it is a component level analysis. It is also called as micro level analysis. The second FMEA could happen to the process which examines the process used to make the product, used to manufacture the product. It identifies the potential failure of the process, I should say manufacturing process, by inappropriate assembly, inappropriate choice of components, etc. So, this is a macro level analysis. Because it analyzes the process, then comes back to the component, whereas design FMEA starts from the component and goes to the product. As we saw in Azov studies, similarly FMEA also has got certain keywords. Let us say basic and secondary functions is one of the keyword being commonly used in FMEA study. Basic function describes about what the product does. Secondary function describes about what the process does. The second definition which is required in FMEA keyword is the failure mode. Failure mode is the physical description of a failure. Third keyword could be failure effects. This is indicating the consequence of failure on overall performance of the system, on environment, on people, and of course on economy also. So, this covers almost all the issues as referred by risk analysis. Failure causes, this refers to the reasons for failure. In fact, to be very precise, the reasons for anticipated failure. Please understand very clearly, FMEA is not a post diagnosis of an accident or incident. It is a pre-evaluation of a product at the design stage itself. So, all failures are anticipated. If the valve does not open, if the sensor does not transfer output, if the microcomputer fails, all these are anticipated failures. Okay? So, anticipated failure, identifying the reasons for those failure, that is what the failure cause. Let us try to ask a simple question to ourselves, what is an FMEA roadmap? What does it actually do, in what sequence the work is carried out? If you look at the algorithm or the steps involved in whole FMEA analysis, as we understand from the example of a car anti-skid braking system, first is we define the system, subsequently we identify the modes of failure. After identifying the modes of failure, we identify the causes of failure, and failure modes. Subsequently, we also identify the effects of failure modes, in this case, we determine two things. One, we determine the severity, we also determine the occurrence. Once we did this, we move further to identify the cause of failure modes, and we determine the occurrence of failure modes as well. Once we did this, we evaluate the current controls available, this is useful to verify the design or the process, whatever may be the type of FMEA you are using, design FMEA or process FMEA. Finally, we are interested in detecting or determine the detectability. Is the failure noticeable? Can you really see? I can give a very simple straightforward example for you to understand. If we consider one of the wheels of a car as an important component which can fail while running, the detectability of failure of the wheel can be easily seen from a deflated tire. The tire is punctured. So, is the failure mode detectable easily? Can you physically see it? Can you physically feel it? Is it visible to the person who is operating the system? Okay? So, that is what detectability is. The higher the detectability, the lesser the risk involved, because you can always stop the machine, etc. For example, you are moving an escalator, the escalator buttons are available at the top and bottom mode of the operation. If the escalator is stuck up, not able to move, is easily visibly seen, so one can always detect that it is not working, and you can switch on or off manually the escalator, so that the escalator motion can be controlled physically by a manual mode of operation instead of automatic mode of operation. So, we would also like to know those failure modes identified by the designer, are they detectable? Is there any mechanism, any provision available in the design which explicitly shows that the failure mode is detectable, or one of the component has failed which can be seen very clearly in a detectable mode. Once we do this, we determine, so we call this as D, we determine risk priority number, I will come to this argument slightly later. Once we know the risk priority number, then recommend actions. To correct the consequences or to improve the design. So, that is going to be the FMEA roadmap, which is generally applied to any system, so that qualitative and quantitative aspects of risk analysis or hazard identification are covered in one shot using this, which is very powerful and very common tool, in fact a mandatory tool for all electromechanical systems in the product development or in product improvement. Friends, I hope you have understood this lecture with an illustrated example of an anti-skid braking system on a passenger car. FMEA is a very simple study which can be reported. We have seen in this lecture qualitatively how to write an FMEA report. Now, we have so far not discussed how to get the risk priority number, which we will discuss in the next lecture. By taking another example or the same example, we will see how RPN can be computed, and therefore, how one can prioritize the risk, and based on the risk prioritized, how one can suggest the recommended actions. In fact, I would request to all the viewers to apply this kind of study for any electrical or mechanical system available around you. Look at the working mode of that particular mechanical system. Take a bicycle for example, take a motorcycle, start applying the study for known products first. Then if you are a petrochemical or an offshore engineer, start looking at the mechanical working mode of a BOP, which is the blowout preventer. Then try to identify the components of BOP and do an FMEA analysis and see amongst the components present in BOP or a drilling stack as a whole, which is the most vital and critical component. This will give you a very good insight of understanding the whole process, which would lead to an accident. Once your understanding about the process is clear, I am sure you are contributing towards the safety assurance to the maximum level. Thank you very much.